Hi everyone, this is the last example, example 7 on flow meters. In a test to determine the discharge coefficient of a 50 mm by 12.5 mm venturimeter, the total weight of water passing through the meter in 305 seconds was 3,410 newtons. A mercury water differential gauge connected to inlet and throat of the meter showed an average mercury difference during the time of 360 millimeters. So determine the actual flow rate, the actual velocity in the 12.5 mm throat, and the meter coefficient. So given the weight in weight passing through the meter in 305 seconds, we can compute the actual flow rate by equating weight flow rate to weight over time. So weight flow rate Q gamma of water equals weight over time. So Q times 9,810 newtons per cubic meter equals 3,410 newtons over 305 seconds. So the actual flow rate is 1.140 times 10 to the negative 3 cubic meter per second. Or Q is 1.14 times 10 to 1.14 liters per second after multiplying that by 1000. The actual velocity in the 12.5 mm throat, so actual discharge equals area of the throat times actual velocity at the throat. So substitute 1.140 times 10 to the negative 3 equals pi over 4 quantity 0.0125 square times actual velocity at the throat. So actual velocity at the throat is 9.290 meters per second. Then 7.3, the meter coefficient. So we will compute first the theoretical discharge given by the formula which I derived in my lecture video. Pi over 4 diameter 1 square times diameter 2 square root of 2gh over diameter 1 to the fourth minus diameter 2 to the fourth. Where h is, you look at the formula for h in example 3 on flow meters, and it is equal to z times quantity specific gravity of mercury divided by specific gravity of the flowing liquid, which is water, minus 1. So it is given by this expression. In that example 3, it was oil, so that's why we have S of oil here in the denominator. So H is 0.36, quantity 13.6 over 1 minus 1. So H is 4.536 meters of water. So substitute into this equation. Q theoretical is pi over 4 times 0.05 square, 0.0125 square times square root of 19.62 times 4.536 over 0.05 to the fourth minus 0.0125 to the fourth times 1000 to convert it to liters. So Q theoretical is equal to 1.160 liters per second. Then finally, meter coefficient is actual over theoretical, 1.14 over 1.16. So the meter coefficient is 0.9828. So that's it for this problem in the laboratory.